Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are H.A.S. Today we will study about filters, particularly active filters. So, what is a filter? The answer is a filter is a circuit that passes certain frequency and rejects all other frequencies. We know about passive elements. Passive elements are those elements which do not process the input signal. By processing, I mean either rectify or amplify or give a phase shift to the input signal. Alright, examples are resistors, inductors, capacitors. We also know that active elements are those elements which process the input signal, like diode that rectify the input signal and transistors that amplify the signals with or without the phase shift depending upon its configuration. Now, the passive filters have voltage gain less than 1 or equal to unity. So we proceed toward active filters, which is our today's topic of discussion. It has two types: active filters, low pass filters, high pass filters, band pass filters. Let's first discuss low pass filters. A filter that provides a constant output from DC, that is zero frequency, to a cutoff frequency, let's say FOH, and then passes no signal above that frequency, is known as an ideal low pass filter. Keep in mind I said ideal. Alright, now that frequency, I just said FOH. You need to know that FOH is that frequency above which no signal will be present, and FOL will be frequency below which no signal will be present. So, ideal characteristic of low pass filter is shown here. At FOH, the gain becomes 0 and we have signal there below it. Now let's see its OrCAD working. This is our circuit for our low pass filter. Let's see its graph. You can see that you have almost a constant gain and then it will go down and finish. The gain is finish. This is the output characteristics of low pass filters. If you go to our high pass filters, high pass filters are filters that provide a signal above a cutoff frequency, that is FOH. Alright, this is high pass filter. This is the characteristics of it in ideal case. Now see OrCAD. This is our high pass filter. If we will place a voltage probe here, alright, as you see above certain frequency it gives output some gain. Alright, now moving on towards third type, that is our band pass filters. It is a filter that passes signal that are above one cutoff frequency and below the second cutoff frequency. Alright, it consists of a high pass filter followed by a low pass filter. It will give a signal above certain frequency which will be accepted by this low pass filter, and it will move it to a certain frequency. The gain will be vanished like this. Let's see. Alright, we have a gain of this filter and this filter. Both of gain will be multiplied to give the resultant maximum gain. Now, how that gain and cutoff frequencies are determined? We have our formulas like this. This is for cutoff frequency. It doesn't matter it's high pass or low pass. For low pass, this will be frequency above which no signal will be present, and for high pass, this will be frequency below which no signal will be present. Alright, that is for low pass this is FOH, and for high pass it will be FOL. Gain is given by this formula, and for band pass filter the high gain pass filter gain is multiplied by the low bypass filter gain, and it gives you the resulting maximum gain which can be achieved. The thing is, the formula are for ideal case. If you see our graph that won't match with the ideal graph, there will be 10% error between them. But it doesn't matter, we should be optimistic. Let's make them again. But again you need to know about the formulas is that these R1, R2, C1 and C2. The resistors and the capacitors are at the same side or plus side of your op amp always. This is C1, C2, this is R1, this is R2. Alright. For gain formula, this is RF and RG. Alright. This is negative feedback resistor, that is RF, and this resistor is your RG. You can apply your formulas and gain or results. I can show you an interesting thing about your formulas and practical. You have to place a prop here. Let's put another one here. Alright. Now run it. Alright. Now first see your mathematics. Your mathematics tell you that for low and high pass filter this is your gain 6, and this is your FOL and FOH, and this. Because my resistors and capacitors are of same values, so this is cutoff frequency. So how it is different, I have already told you. For high pass filter it is FOL, and for high pass filter it is FOH. If you see your graphs, alright, this is the frequency should be same when the gain is vanished, but it's not. Because in reality it is not fall to 0 when it has achieved 1.5 kilohertz. But in mathematics, the cutoff frequency is 1.5 kilohertz. I think I have made my point clear. This is for low pass. It should vanish here, the gain, alright. This is high pass. The gain should start from here, but it's not. Alright. So this is how you can see your ideal cutoff frequency in OrCAD. Alright. Now we will make it again. Now the thing also is your gain. In low and high pass filters it is okay, but when you see here in band pass filter, the gain here is 1 plus 50 over 10 is equals to 10, or is 6, sorry, and 6 into 6 is equals to 36. So maximum gain which can be achieved, but it is here 32 almost. You can see from boxes it is approximately 32. So that's why I said that there will be approximately 10% error in our practical and mathematics. Alright, now let's make it again. All the three circuits. Let's make it, name it H.A.S. Okay. Create a blank project. Okay. Now edit your simulation profile. Name it first H.A.S. Okay. Alright. This is our simulation settings. Now this time it will be AC sweep. If we start from 1 Hz and go to 100 kilohertz, points will be 100 every time. Okay, let's make our circuit. Low pass filters UA 741 eval. Place it here. Alright, now VDC rotate by R here and here like this. Place wire, have to connect it like this and this. Now ground. Resistors. Give them values. Alright, ground here, this is 50 kilo, this is 10 kilo, this is 10, and this is also 10. Alright, now we will copy it because it will be used again. So we are using the copy paste amazing trick later on for saving the time. Now we need to put resistors and capacitors at input side. Capacitors, one here and one here. We have to put our source now, that is AC source. Put it like this. Let's connect them by placing wire. Alright. Now our capacitors like this, like this. second capacitor like this. Now piece by ground here and here. Now give them values. R1 should be equals to R2 and C1 should be equals to C2. Zero 0.05 microfarad. It will be again 0.05 microfarad. Alright, let's put our voltage props here and run it. This is your graph. Low pass filter. For high pass filter, all we need to do is replace the capacitors by the resistors at the input side. Alright, like this. Now resistors, place it here and here. Again we have to change their values. This is it's 2.1 kilo. It's small k, remember this. This is also 2.1 k. Alright, now let's run it. Run piece piece. This is our high pass filter. Now for band pass filter, all we need to do is to put our low pass filter next to this high pass filter. Alright, as we have copied that circuit, as it's gone, so I'm again copying this, copy and paste. Here it is. Alright, now all we need to do is to put our resistors and capacitors. This and this. Now capacitors, this and this. Now piece piece ground, the most important component of any circuit. Now simply connect all the components. Like this, and this. It's completed. Now we have to value our components. It's 50K, it's 10K, it's 10K, it's also 10K. Now capacitors, it will be 0.002 microfarad, it will be 0.002 microfarad. Now what we need to do is to make a starting cutoff frequency and an ending cutoff frequency. So what will we do is the R1 R2 of this filter same as this second filter. The resistors of first filters are different from that of second one, as you know the cutoff frequency 1 over R1 R2 C1 C2 under root. I think that's all about it. We have to put our voltage probes here, and we need to change the capacitance value from here. It is 0.1 micro, it's small u. It will be 0.1 micro again. Resistance will be 10K. Again it will be 10K. Alright, that's it. Now run our circuit. Let's see. Yes, exactly, it's the same. This is our band pass filter. That's all for today. Thank you for watching. Allah Hafiz.
Guys, don't forget to subscribe down below and also give this video a big thumbs up and don't forget to comment down below. The dot.